Now we'll start talking about the laws of light refraction. First law indicates that relative refractive index between two medium and 1, 2 is equal to the ratio between the light speed in the first medium to the light speed in second medium, or ratio between sine angle of incidence of first medium to sine angle of refraction second medium. So n1, 2 equals sine phi over sine theta. So n1, 2 is v1 over v2 equals sine phi over sine theta, which is a constant between two medium. Now, second law of the light refraction: incident ray, refracted ray, and the normal line, they all in one plane which is perpendicular to separating surface. Note the light velocity in high dense medium is lower than less dense medium. This means that speed of light in medium is inversely related or inversely proportional to the density of medium of light. When light passes from high dense medium to low dense medium, what happens? If this is a separating surface between two medium and the first medium has higher density than second, so this is angle of incidence between incident ray and normal line, phi. So if angle of incidence in first medium, which has higher dense medium, the speed of light here is low, and the light speed in second medium will be higher, so the angle will be more, then angle of refraction will be more than angle of incidence, and light refract away from the normal line. Inverse case, if the light fall from less dense medium to the highest medium density, this is separating surface. If this is medium is low, and it will pass to higher dense medium. Where is angle of incidence? Yes, this is phi. If this has low density, so the light speed here more than second medium, so the speed of light decrease, and also it will refract near to the normal line, and angle of refraction will be less than the angle of incidence. Okay, now I have to know or to study the absolute refractive index. It is the ratio between the sine angle of incidence in the first medium or air to the sine angle of incidence in the other medium, or speed of light through air, which is symbolized by c, to the speed of light in the transparent medium. What are the relation between absolute refractive index and relative refractive index? Consider two media where light velocity v1 v2 respectively. Their absolute will be n1 equals c over v1. Okay, so n2 also c over v2. Note that c and v is inverse related, so n2 over n1 will be v1 over v2 will be n2 over n1. So v1 over v2, from the previous slide we know that it will be n12 or relative refractive index. So n12 v1 over v2 equal n2 over n1. So n12 relative refractive index between any two medium equal second absolute refractive index of second over absolute refractive index of first. If the light velocity in glass is 2 times 10 power 8 meter per second, calculate refractive index of the glass. Okay. The rule, n glass equal c over v velocity of light through glass. 3c is speed of light through air, 3 times 10 power 8 equal 2 times 10 power 8 equal 1.5. Note that there is no measuring unit of absolute refractive index because it's a relation between two equal physical quantity. Number 2, absolute refractive index here is more than 1. Oh, absolute refractive index always more than 1. Why? Because that ratio between the speed of light through air and speed of light through medium, and the speed of light through air higher than any medium. Another example, if light fall on the glass block whose refractive index 1.5 with angle 30, find the angle between reflected ray and normal line. Okay, look at this. The question now, this is angle of incidence 30, and this angle of refraction I can know it. I can calculate it. This refraction. The question, what the measuring between incident reflected light ray or refracted ray, these two rays. I'd like to get this angle. Number 1, angle of reflection equal angle of incidence equal 30. This 30, so it will be 60. I'd like to get it. N glass over N air equals sine phi over sine theta. So the sine theta will be sine phi over N glass. It will be sine 30 over 1.5. Theta will be 20. So theta 20. So the remaining of this right will be 70. And also is this 30? The result will be 130. I can answer it by another way. This line angle 180. So 180 minus 30 and minus 20, it will be 130. If absolute refractive index of water is 4/3 and that of glass is 3/2, this N water, N glass. Calculate relative refractive index from water to glass and then from glass to water. At the first, what is the rule? N from water to glass equal N glass over N water. After it, calculating 9/8. Then, if I would like to get relative refractive index from glass to water, it will be reciprocal of it, 8/9, or I get it by the rule. Example 3. If light wave whose wavelength lambda equals 600 nanometer fall on a liquid forming an angle of incidence 30 with its surface, knowing that the angle of refraction theta 45. Find the wavelength of liquid and refractive index of liquid. The answer from the given lambda 1 over lambda 2 equals sine phi over sine theta. From where means lambda 1 over lambda 2 the same V1 over V2. So 600 over lambda 2 equals sine 60 over sine 45. Lambda 2 will be 489.89 nanometer. This is the number 1. Number 2, N liquid over N air equals sine phi over sine theta. N liquid over 1 equals sine 60 over sine 45. Then refractive index of liquid will be 1.22. Thank you.